Welcome to Lesson 3-1, the distributive property. We're going to use the distributive property to write numerical and algebraic expressions today. But before we begin, let's talk about equivalent expressions. Those are two expressions that have the same value. An example would be something as this. 3 times the quantity of 4 plus 2 is equivalent, or the same, as 3 times 4 plus 3 times 2. What makes them equivalent is that they're both equal to 18. Alright, the key concept is the distributive property. In words, it is to multiply a number by a sum. Multiply each number inside the parentheses by the number outside the parentheses. And we have some symbols here, are the algebraic way of looking at it. And then we have a couple examples here. Just like the previous problem, we have 3 times the quantity of 4 plus 2. We have multiplication, which is the parentheses. And we have the sum, which is the addition sign. We take the number on the outside and we go ahead and distribute it, or multiply it to each number inside the set of parentheses. That's where we get the 3 times 4 and the 3 times 2. Notice that the plus sign is still in between them, and we go ahead and solve. In this slide, we're going to use the distributive property to write each expression as an equivalent expression, then evaluate the expression. So we're going to suspend PEMDAS. Normally we would add in here the 4 and the 6. We're just not going to do that just to show the distributive property. So what we're actually going to do is go just 2 times 6 and 2 times 4. You can see I just did the distributive property. Now the second part of our directions say to evaluate the expression. So what we're going to do is we're going to find the answer. Multiplication comes before addition, so we have 12 and we have 8. Bring down the plus sign. Add those two numbers, 12 and 8 together, and we get 20. All right, let's do that again. Notice that the 5 is on the back side of the parentheses. It's still multiplication, as we have learned that a number next to a parentheses still means to multiply. So we can do the distributive property. So here's a little, for those of you who haven't had experience with this, here we go. I'm going to distribute the 5 to the 8 and to the 3. There, you can see the distributive property. 5 times 8, 5 times 3, add them together. Let's evaluate. So 5 times 8 is 40. 5 times 3 is 15. Multiplication before addition. Go ahead and simplify 40 and 45. That's 55. And that, ladies and gentlemen, is the distributive property with numerical expressions. Alright, we're going to solve this problem in two different ways. It's an amusement park. We have a one-day pass to an amusement park that costs $40, and a round-trip bus ticket to the park costs $5. This first method would just to find the cost for one person. For one person, it's $40 plus $5. So that's one ticket. But there's going to be 15 of us. So I'm going to go ahead and take that price of 1 and multiply it by 15. The second method would to individually find the cost for the pass for 15 people plus the bus pass for 15 people. And that's two ways of setting it up, and they're both equivalent expressions as we've learned in our definition. Our last thing we need to do is find the total cost. In method 1, you can see that I added the 40 and the 5 and got 45 times 15. In method number 2, you can see that I multiplied 15 and 40 and got 600. 15 times 5, I got 75. What is the total cost? Since they're both equivalent equations or expressions, it is $675. Alright, in this slide it says use the distributive property to write each expression as an equivalent algebraic expression. We're using algebra, meaning that we have variables. In this case we have an x. So this is 3 times the quantity of x plus 1. Alright, so we're going to use the distributive property. We don't have to do PEMDAS. We cannot add x and 1. So that means we're going to go ahead and go to our next is multiply. And we're going to use the distributive property to multiply. So I have 3 times 1x plus 3 times 1. I'm going to go ahead and simplify that to 3x plus 3. And that is our answer. Alright, we're still using the same direction, so we're going to use the distributive property because we cannot use PEMDAS, we cannot add y plus 4. And we've seen a problem like this before. It still means to multiply even though the 5 is here. So we're going to go ahead and distribute. And notice once again, I'm going to both numbers inside the parentheses, not just one, but both. So what do I have here? I have 5 times 1y plus 5 times 4. Go ahead and simplify that to 5y plus 20. That is our answer. Alright, here's something new. We have a subtraction sign in between the x and the 1. We're going to go ahead and treat it like we normally do. We're just going to go ahead and distribute. And once again, that 2 is going to go to both numbers inside the parentheses, not just one, but both. So now I have 2x, or 2 times 1x. I'll keep the subtraction sign. I have 2 times 1. And we go ahead and simplify. 2x and 2 times 1 is 2. And that is our answer. We'll continue on with the directions. We're going to use the distributive property. But I'm going to have to do a little work beforehand. I noticed that I have a negative on the outside and I have a subtraction. I'm going to do something that I learned in Chapter 2. Is that I'm going to go ahead and change my subtraction into addition, and then I'm going to go ahead and take the inverse of 5 and make it a negative 5. Now that's going to help me out. You can see here I'm going to have a negative 3. I'm going to times that by 1n. I am going to have a plus sign because I made that change there. And then I'm going to multiply by a negative 3 and a negative 5. Negative 3 times 1, signs are different, so I'm going to get a negative 3n. Bring down the plus sign. 3 times 5, the signs are both the same, so it changes to a positive, so I have 15. And I look, and 3n plus 15, I can't simplify anymore because they're not like terms. There you go.